Hello Eli, sasa hapa hivi I want to do a little demonstration of what is going to, how the communication will take place. We will have a master controller, which is an ESP, which will be connected to the cloud, and the master controller, which each master controller, which is an ESP, will be able to take care of several module access. In this example, I'm using 5, but you can be able to use up to 8. We will use addressing, hardware addressing, which will be able to ensure that we know each device and what it is used for. So let me get down to the point, and you can be able to see what is happening. So let me just take this example. I've put it on. All these microcontrollers are running the same code. Oh, it hung on 2, which means that the code is not correct. Let me check that. So yeah, this is using the wrong code. Let me do something like this. Let me copy the code here. Let me copy the path. How do I do that? Let's copy the path. Then put it here. Just remove the quotes. And then let's put some quotes here. So it's going to be like that. That's the code. I hope each one of them is running the correct code. Yeah, all of them are now running the same code. So when we do this, all of them should register themselves to the network. So you are 0 registered, you are 1 registered, you are 2 registered, you are 3 registered, then you are 4 registered. Remember, each of them is the data is flowing anti-clockwise. The data is flowing anti-clockwise in this situation. So now, for instance, I wanted to speak to the important thing is that each of them should be able to know its address, and once it knows its address, the data that has been sent, although it goes through all the devices, all the module X's, the module X that requires that data or is addressed to should be able to know its own data. And for this example, I'm using an example of lighting an LED, because as you can see, each of them has an LED. Each of them has an LED, and we can be able to light each LED to be able to know which one. So this is module 4. I've used these 3 pins to do that. You can be able to look at the figure later and be able to figure out how to connect them. When they are all shorted, it means that all of them are grounded and all of them are zeros. Then there is 1, there is 1, there is 2, there is 3, there is 4. So let me send some data using a formula that I have come up with, which is start with hash, meaning the code is beginning, then put X, which is the address of the microcontroller you want to address, then take the data that you want to send to that microcontroller, and then terminate the string with a $sign. And in this example, let me speak to number 2, for example, hash 2. Then I can be able to write 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I put a $sign, and that data is being sent as we speak. So give it some moment. As the data flows, you'll see this LED lighting once the data gets here. And as the data flows, you will notice that here you cannot be able to see that I typed data, but that data is supposed to move. This one will only display what has come back, the received data, because it is a debugger. So you see the data has reached here, so the data is still flowing, it's coming here. As you can see here, the timing, it's not flowing in real time, and these are errors showing that it's not actually running in real time. As you can see, the data has been able to go through, and all that we typed, which was hash 2, which means the address, then 1, 2, 3, 4, 5, all the way to 9, we sent, and it has come back to the controller, which has now showed us this. And this controller now can be able to verify whether the data actually went in the right, unaltered and came back. And that is the point. Of course, we can have the microcontroller. We can also use the microcontroller we are using for debugging, as we will be connecting it to our computer and we will be able to see. And in most cases in debugging, we want to use the UART to send that to see what is happening, and it won't have an effect on what is happening to the modules when in the testing phase, because if I write, for example, my name write it wrongly, but if I write my name, that data will be sent back and my name will come back there. But that data, because it doesn't begin with the #2 and end with the $sign, it doesn't matter. The microcontrollers will basically just pass on the data. They will basically just pass on the data because they don't know what is the beginning of the data and what is the end. To illustrate that the data is beginning, we have to start with a hash. So basically that's how the microcontroller will be programmed. The controller part will be programmed to be able to send data and to be able to be used for any other purpose of serial interfacing or serial communication. If we wanted to connect another basically that's how we'll be able to communicate with it. So that is basically just how this thing is going to work. So let me just stop the video there to make it short, but for an illustration, for example, is as you can see that we were able to light LED number 2. We can be able to use that to, for example, we have an irrigation, and this is a temperature for probably looking at the moisture, temperature, humidity, and all that, anything that we would require in the garden. Using this microcontroller, we can be able to send data to it to read the information, and based on the information we can be able to say, for example, switch on the generator and probably to pump the water. So let's pump the water in LED number 4 because this will be very fast. It's as close as possible. So put a hash, then send water, for example, and we do a $sign, and the data should be sent. If we started with #4, I'm not sure that's what we did. I'm not sure that is what we did. Maybe it's not what we did. So if it's not, let me just be sending something else. Let's say #3. Weka maji. As you can see, it sent, but sent water. There was no address, so no one owned that data. But now that we have put 3, we expect to see this one watering exactly. Now the watering will be done and we will be able to do that. So let me just stop there with the demonstration, and we can be able to know to do what we will do. Of course the data is still flowing, that's why it's not yet reached here. But once it got here, this one executed the command before the data came back to this, and that's it. That is the point of our demonstration. So let's just stop there and we'll continue